Okay, I will record this session. Okay.
Good morning, everyone. We have a webinar this month. This is the last seminar of the year, and we have 11 participants from Korea, Taiwan, and one more person from somewhere.
Vietnam?
Vietnam?
Yeah,
welcome.
Vietnam, thank you.
Oh, yes. Good morning.
Hey, good morning. Don't know why my camera is not working, but anyhow.
Okay. So please, Jason, would you read this webinar from now on? Jason?
Good morning, everyone. This is Jason from Taiwan. Today, I would like to introduce this paper. The topic is crowd-based observation of riverine microplastic pollution. Okay, so I will start from the abstract. Microplastic pollution larger than 0.5 centimeter negatively impact the aquatic life and threaten human livelihood on land, in ocean and river systems. Reliable information on the origin, fate, and pathway in plastic in river system required to optimize prevention, mitigation, and reduction strategies. I think probably because this abstract is quite long, I don't have to read all of them. So I think I can start from those because they have many figures and tables. So I think I will quickly review all the figure and tables. So let's go to the figure 1. So because these people use a mobile application to survey or to record the riverine debris, which is floating plastic and the plastic on the riverbank. So they set 8 categories of the amount of or the number of plastic, from no plastic to 1 to 3 to 1 to 2 pieces and 3 to 5 pieces. So you can find it's increasing in numbers, and it's in some different orders increasing. And so the largest is covered by entirely, and the second largest is 100 plus 100 more pieces of plastic items. So this is the definition of counting classes, these 8 classes in these crowd water applications. So this is figure 1, and in table 1, they use a quite unique plastic category to separate those floating or riverbank plastic into these 7 categories. So this, which is PET, PS, EPS. I think this is common, but they have PO soft and the PO hard. And in their explanations here, PO soft and PO hard, all related to polyethylene and polypropylene. And soft, probably many are shopping bags and foils, and hard it will be some kind of containers like bottles and bottle caps or rigid plastics. So they kind of simplify the previous or traditional data sheet or category, debris category, into these very simple 7 categories. And so the last one is multi-layer and other plastics. So this is table 1. Here's figure 2. Figure 2 is a map of a river in Malaysia, which cross the capital Kuala Lumpur, and the river is called River Kelang. So all the floating in this river, they did a floating plastic survey on this bridge, and they separate this bridge or river section into 3 sections, 1, 2, 3 sections. So I will explain this later. And the second study area about the riverbank plastic is in the Netherlands. It's a very close to the river mouth of River Rhine. And so this is about, I think it's about 15 kilometer length of the riverbank here, and on the right side of this bank, they survey the riverbank plastic, the amount of riverbank plastic. Okay, so let's go to the result table and figures. In figure 4, there are 6 figures here, and this figure 4 is all related to floating plastic in the river in Malaysia. And at the left side, the x-axis is the date. So this survey from end of April to beginning of May. And at each day, they took several times, and each time they took the 2-minute survey on the bridge. So you can see the y-axis is the density, the transportation or density. Yeah, in 1 hour, how many plastic items pass through this bridge? Kind of this idea. So this, the figure A, B, C, you can see it's segment 1, segment 2, and segment 3 inside that bridge. So at the right side, it's a daily mean plastic transport segment. So they combine all the samples between 1 day into one number. It's a daily mean plastic transport segment. But there are 2 different methods they used in this paper. The light yellow circle is standard, and the gray square is core water, which is used a simplified method by the mobile apps. So they will compare these 2 data. One is a standard and traditional method. Another one is the simplified application app method. But you can find it's quite similar. Compare these two data set, 2 methods. But sometimes it's different. Like here in this state, it's different. In this segment 3, and in between April 29th, so the data is quite different. The standard method counts a higher number of plastic. By the groundwater, the apps can record less number of plastic. So this is about the floating plastic in figure 4. And the next figure 5, they compare these 2 different methods to see is there it's kind of the correlation between these 2 methods. So compared to these 2 methods by different segment on this bridge or on this river. So in segment 1, the correlation is correlation coefficient is the highest. It's very close to 1. So you can see if there's more dirty or more plastic calculated by the standard method, there also will be more plastic calculated by the new method. But the correlation is relatively low in segment 2 and a little bit lower in segment 3. And in total, it will be like this, the number 5D. Okay, so next is a river bank. So it's still the floating. So they compare the floating plastic, the daily mean plastic transport, and separate by different date. So you can see sometimes they will be very similar, but sometimes it will be different. And the figure 6b is the distribution over the river width. Because this river is quite long, so it's about 100 meter. Sorry, this river is quite wide. So they separate at each segment will be around 35 meters. So you can see at the middle of this river, the contribution of this segment will be the highest. It means most plastic transport in this segment 2. It's in the middle of the river, and in both methods they find very similar trends. And in segment 3 will be the lowest, but you can see it's quite similar. And in figure 6c here, it's a composition of the different plastic category. So you can see the standard method and the new method called water, and they separate those plastic into 7 categories. So you can see the composition is also quite similar. Most of the plastic is PO soft, which is bags and films and foils. And the second one is the EPS, the styrofoams. So it's quite similar here. Okay, so the next figure is the river bank. They do the river banks survey in Netherlands, the river mouth of River Rhine. So in figure 7a, the x-axis is the length counting from the estuary, the river mouth, from 5 kilometers to 15 kilometers. And the y-axis is the counting, the count of the plastic. So from no plastic to more than 100 items. So you can see these squares are the data. They have many surveys find there's no plastic, and sometimes there are 1 to 2 items, and sometimes the largest will be 11 to 20 items. But at each survey or at each location, the length is different. This is very important. So that the surveyor will record how long they walk along this riverbank and counting the plastic. So the length is varied from 1 meter to 10 meters. So at figure 7c, they combine these two data and transfer into density. It means the length density in 1 kilometer. How many items in 1 kilometer? So they compare the density between traditional method. They only took 3 surveys in this whole river bank, and at the 9 kilometer from river mouth, 10 kilometer from river mouth, and the 12 meter from river mouth, which is light blue circles. So all the grays at this figure, all the gray squares are calculated or collected by the new method, and the light blue is the traditional method. But all of them still in the same range. I mean, the minima and the maxima it's quite in the same area, in the same range. Okay, so this is, I think it's all the, oh, they have another figures here. So they put the those dots at the maps. So this River Rhine at Netherlands. So all the squares are using the new method to calculate the land density, and the circle ones means use a traditional method. So you can see the like the distribution or hotspot in this area. And in the articles, they said that they note that there's more. I mean, there's less density in this area. You can see there's a lot of small green squares here. It means there's no plastic, very close to zero. And they say because it's a Euro area, the population probably is lower. So this is probably there's less plastic. That's why there's less plastic here. Okay, that is all the figure and tables. Oh, we can go to the supplemental materials. They also have some figures here. And let me introduce the app first, I think. I already downloaded these apps. It's very easy for people use smartphone to download and install these apps. You have to make a registration, and in this area you can choose the location where you do this survey. And originally this apps is designed for some hydrology purpose, like the water level, soil moisture, and the temporary stream, or the flow speed. Sorry. Excuse me. But now they extended the functions. They give it more function. It's called plastic pollution. And the plastic pollution, you can update your photos from your album, or take the photo right there, and you can choose you do the type. You can do the floating plastic or plastic onshore, which means riverbank. And there are many options here. Like if you choose a floating plastic, I think it's quite easy. You take only maybe less than 5 or 4 steps. You can upload one data. But if you want to contribute more details, you can still provide more detailed data. And one of the detailed data is this. I think this is quite interesting because in Taiwan we use very similar to method to calculate the composition of shoreline debris in our rapid assessment survey. So because it's very difficult to collect and count and to do the countings, but if you give people like this the proportion, people probably feel easier to choose the proportion of the items they use. They only use visual countings. For example, if I think doing this survey, I feel this very much taken by the PET bottles. Probably I will think it's 80 or 60% of all items I count is PET bottles. But you don't have to give the absolute numbers. So it's much easier than pick up and counting everything, and it saves the data you can upload. So okay. Okay, so I can start from. Do you have any questions?
No questions from floor. Please go ahead.
Okay, thank you, Sunny. I can show you. I already upload some of two data this morning. So one is a riverbank. You can see the screen share because I took some photos earlier this year and last year. So I just uploaded photos from my cell phone albums. So this is on riverbank. So these are some very simple compositions like POSOF. It took 80%, and the PSE actually is EPS. I don't know why it's PSE. PS expanded. It's to 20%. So now for me it's I already contribute two data, and another one is riverbank. I took this photo 1 year ago, but I can still upload it, and I choose the location, and the data is very similar to the floating, very similar to the riverbank. This is a floating data, so it's floating plastic. Okay, so it's kind of like how I upload the data. So I can choose the proportion of the river I do the observations, and I can choose how many plastic. So only 8 category, only 8 classes from 0 to entire the whole service. And how long did I observe from? So the minimum is 1 minute. Stand on the bridge for 1 minute. Okay, so I think it's quite interesting for these apps. So I start from the introductions. So everybody knows the microplastic threaten to the species through entanglement and injections. And in urban water systems, blockage of hydraulic infrastructure by microplastic lead to more severe and faster water level increase compared to organic debris like driftwood or leaves. And so river plastic is assumed to be a main source of marine plastic pollution. But this the mechanism, the drives may lead to natural drives like wind, surface runoff, river flow velocities, and anthropological drives like land use, waste, and water infrastructures. So in earlier works, those river plastic data collected by net sampling method, but it's labor intensive and require additional equipment. So because it's very difficult, so seasonal variation it's still remain uncertain. So the visual observation is a new method. And for the visual counting method, the observations are made from bridges. And it will be easier for volunteer or non-professionals. And so because it do not require additional equipment and infrastructures. And despite this simplicity, and this method also allow to collect the quantification of plastic transport or seasonal variation and compare the between rivers. And there's something about city and science can be very kind of cost-effective method, while also raising public awareness on this topic. So they use this mobile application called Quant Waters. So Quant Water originally developed to collect hydraulical data on stream water level, the soil moisture, and the state of temporary streams. They extended excuse me, extended with a module facility data collect on floating plastic and the plastic on riverbank. So it's a new functions in these apps. So they will try how it works in this new function. So at the method part, they mentioned that this paper, these apps not only use in this. Sorry, excuse me. Not only used in this paper, but they mentioned they have another project called Plastic Spotters. It's really a citizen science project to quantify the plastic transport in urban canal systems. And I found this paper too, and I think it's more. I mean, this paper is written after our seminar paper, so it's quite similar, but they introduced the whole process of citizen science from 1 to 7 steps to mapping the hotspot of this canal system, and they have some infographic to introduce their 7 categories of the plastic, and they also have some maps. So they just ask those surveyors to walk along this canal and to record the amount of plastic along this canal, and it can be, the map can be drawn in a very quick and easy process. So that paper already published after this one. So after introduce the apps, they introduce the floating plastic. The traditional method is about the visual counting. It's developed by this author and this one, but the first author of this paper, the Tim Van Emerick, has made some adaptations. So the adaptation include they only focusing on macroplastic versus to all man-made litters, and expanded the multi-measurement point along the river width versus only one location, because some river the width of some river may be very big. So the duration of the floating plastic recording between 2 and 30 minutes, and the observers can choose they want to, if the river is small, they can cross the entire width or only a fraction, like 1/3 or only a portion of this river. And they also can provide information that if after I recorded this data, I remove this trash or not. For each categories, they mention about how they record the composition of the plastic. So in the application, as I mentioned, they provide from 0, 20, 50, 60, 80 to 100% of the composition of each crash, the fraction of the plastic. And then they also mention about these 7 simplified 7 categories. But the author said, know that some simplification and assumptions are made here. For example, straws fall under the polystyrene categories. Like here, the PS, polystyrene, they put a straw here. But as I know, most straw are made from polypropylene, not polystyrene. But they say, however, this method does provide a reliable first-order estimate without the need of laboratory analysis. Excuse me. Okay. So about the method on plastic on riverbanks, they use the same method, but they can choose the type is different. So people can choose whether they walk along the riverbank for 1 meter long, 5 meter or 10 meter long walks. And the width extend from the waterline to the higher waterline or riparian vegetation. I feel it's not very clear here because based on our experience, the volunteers sometimes will confused about where's the upper and lower limit for there to counting the plastic, especially for in some cases if the plastic is just on the edge of the riverbank. Some people will don't know if that should count or not, and so they use the same classes, the A classes, and the same categories for the floating plastic method. And this here next page, they say the main difference between this new protocol and the extending traditional method is the specifications. Oh, 有草莓。下次叫你去。Sorry, excuse me. So the traditional method, the river OSPA method, people has to divide those items into a very big and long list. It's 100 item categories, and they also require a minimum sampling length of 100 meters. So it's very time consuming compared to the mobile app ones, and then it's not suitable for general volunteers. Okay, they have some information about the survey locations. So in the floating plastic in this Malaysian river, so the measurement will take every half hour to hour from April 29th to May 4th between 9 a.m. to 5 p.m. But I found, because I download the supplemental data, I found there is something is unclear in their data. I can show you here. They say this is the data collected from the floating plastic by the mobile apps. I think they gave the wrong files. All these files is related to water levels, and something is not related to plastic. It's water level and soil moisture. And this image, as I open it, they are not plastic data. So I think you give the wrong data here. And about because in this river they do the traditional method, so you can see actually the data is not simultaneously counting, or so there are some like it's not from 9, sometimes it's from 9 a.m. but sometimes it's start from 11 a.m. So it's quite different. And the data is collected by students, by school students from bachelor and master students. And so the student will separate into groups, and in some groups we have to use the mobile method, and some groups will use the traditional method at the same area, but in different times. So they say the main difference are the data is absolute numbers, which is the standard method, or this is classic spaces, is called water. And the second difference is the 20-step composition categories versus absolutely values for each category, which is the standard method. And all observation, well, duration will be only 2 minutes for both methods. And there's a function they transfer their raw data into numerical value, which is items per hour. I think it's quite simple to understand, which is in that data, the minimum of the category plus the maximum of the category and separate by 2, which means I can explain by this figure. Probably like here, if one data collected by the mobile app said in 2 minutes, they said it's 3 to 5 pieces of plastic cross the river. So the transportation will be 3 plus 5 and cross 2. So there will be 4. It's very just the mean of this mean number of this category. But in here they explain if people choose this category, the upper limit will be 300. So the mean will be 200. So if people choose this category, these classes, so they will use 200 pieces. And they say that there's no data shows any record on this label, on these classes. Okay, so that is the floating ones. In case 2, which is the riverbank, they also show a function here. Oh, sorry. Here you can see the surveys done by first year of bachelor's student, science student. And the survey time is very short. It only do it from 11 a.m. to 3 p.m. on a single day on this river bank. And these locations are it's quite uneven, or because each location separate between the space between each location are 10 meters to 1,800 meters apart. And so those students will be separated by groups, and each group will take 5 assessments. And they can choose they want to do a 5-meter long or 10-meter long sampling area. And they use very similar function equation to turn the raw data into density data, the length density data. Also the minimum of the class and the maximum of the class in the cross by 2, and extend into 1,000 meters. Okay, so about the reference measurement, the traditional method, they only do 3 because it's time consuming. So they only pick up 3 locations from 9, 10, and 12 kilometers from river mouth, and use this OSPA protocol, and only do 10-meter stretch, and calculate and categorize those items into 100 categories. 我帮你看一下。哦，好，我等一下到给你嘛，我在开会。Okay, so let's go to the result. Do you have any question by now?
No, so far so good.
Thank you. Thank you. Okay, I think I already mentioned about this 哦，好，等一下帮你写哦。I think I already mentioned some of the results in while I expand the figures. Okay, about the floating ones, they say it's quite similar from the new method to the traditional method. And the largest difference between these two methods is on the data observed on 29th and 30th in April. And this is mainly due to the high peak value on these days that were missing by the standard observations. So we can see it here. So in these days, there are some peaks here, but it's different. Or we can see it here that it's very different here. Well, let me check this. So you can see that there are some difference here, but sometimes they will be similar. The density will be the transportation amount will be very similar. And they discuss about the difference between different segments. They said because the flow velocity is likely to highest in the middle of the segment. So that's why here, the figure 6b in the segment 2, which is the middle of the river, will contribute the highest level of floating plastic. And in segment 3, they said this is lowest probably because of the geometry difference. Oh, excuse me. So you can see in this river, this is segment 1, 2, 3. And actually, the segment 3 is in the corner of this river turning. So probably the water velocity will be highest in middle and the outer areas, and will be slow in the inner bank, inner area here. So probably because the difference between the shape of the river. And they said the composition is quite similar, but there's still some difference from 0 to 6% point difference, which is this table here. So the groundwater is very easier for people to recall the composition compared to the standard method. People has to separate those into very detail and count each items. Okay, that's it, the result in floating. And the result of riverbank, there's less discussion here, I think. Last result. The range between 0 and 4,000 items per kilometer. And the OSPA master is at different location areas suggests that the density will be 100 to 1,600. So you can see the OSPA, the range of the OSPA is still in this range. Okay, and they say 12 out of 19 locations in some area, in these 9 to 12 kilometer areas, there's no plastic items on the riverbank, probably because this is the rural area and the unurbanized centers. Okay, at the discussion part, this is, I think I can skip some part. This method is, the result is very similar to the standard method. And in some river system, the majority of plastic transport can be occurring in a very limited of time, in a very short time, and the data collection with a higher spatial and temporary frequency will be easier if we use this mobile applications. And so this groundwater is very quick. Within a couple of hours, 38 measurements was done on more than 8 kilometers of riverbank has been sampled in our test study. With the standard river OSPA method, only 3 measurements were done. The classes boundary could combine for some categories for low count, making the high count class more specific. There are some improvement here. Suggestion for further improvement. And about the river bank plastic density, it may be useful to allow user to also report the exact amount of the counting items, because sometimes it varies. And for wider rivers, because some river may be very big, 4 segments may be too limited for the accurate estimate. And they mentioned the Saigon River in Vietnam, because the river is quite big, so they separate into, I think it's 10 segments. So predefined categories are good for inexperienced users, but also a limited flexibility in making observations. Oh, and this is a very good point here. Smaller sampling lengths, especially shorter than 10 meters, may lead to observers' biases when citizen scientists only report observation for hotspot. So it's a very good point, because if the sampling site is not random, choose by people's decisions, so probably there will be some bias, especially the length is too small. And they found there's a weak correlation between sampling length and the mean plastic density. So it's very interesting here. Most macroplastic study on some focusing only on some large rivers. So the citizen science can focus on some smaller river or some rivers without people's notifications. So they said some not so popular rivers already do the survey in these apps. And very important that long-term data is very important, because the available floating macroplastic data spend 1 year at most, and the riverbank only 1 and 2 twice a year. Okay, I think that is my presentations. So do you have any questions and comments?
Thank you very much, Jason. Please turn on your microphone. And do you have any comment or question for the paper?
Hi, this is Boris from Vietnam, Green Hub. Thanks, Jason, for helping me to understand the paper much better after your explanation. So thanks very much for that. I think it's a very exciting approach for rivers, because as you know, rivers are not as sampled as much as beaches and coastal areas. So I think it can stimulate a lot of interest in use for rivers. At the same time, I think for all the reasons that Jason mentioned and also in the paper, that there still has to be some very solid training in the use of the methodology and the application, because the title talks about citizen science, but if we want it to be scientific, then basically there has to be a managed use of the methodology, of the technique. So I think in terms of, let's say, applying this in a local site somewhere, anywhere, it would be nice to have a training manual, a user manual that guides people in the use of the methodology and the problems that may arise by not sort of being scientific about it. To note that the observers used, or the volunteers, were all science students at university level. So in a sense, this is not really an example of a person in the street sort of plucked out as a volunteer to apply the technique on his or her mobile phone. So I think the application of the methodology would be helped a lot by having that as well. So I think I have other stuff, but those are the two more important things. Oh, last point is that it's very interesting to compare the standard traditional method with this new method. At the same time, although there seem to be in many cases consistency or close readings in both, or differences, the standard method could also be misapplied, not used properly. So I think we need to be very careful in all, whether technique, standard, or new, or citizen science or not citizen science, that we still are very much in control of the methodology, and we're not sort of seduced or attracted slowly by the technology and not the science. So just those couple of comments. Thanks.
Thank you, Fabrice. Any other question or comment?
Jason, Chang from Green Hub. I have a question that if we use the apps and we do some survey like a guidance, so can you check the data from this? Because we also have an experience to use, for example, with Ocean Conservancy as well or something. But when we entry the data is run out to the system of Ocean Conservancy, we cannot check the data later on.
Jason, can you answer the question from Vietnam?
Yes, this is a very, very good question. I think I can check if I can download my personal observation from my cell phone. But I feel, because I can view all the data all around the world, but I don't know I can download the original one or raw data by myself or not. I can check and reply you later. Sorry.
Okay.
Yep, thank you.
And for clean swell data, we can download the data from the database TIDES website of Ocean Conservancy. But if you want to find out the exact data you entered, you need some kind of naming of a group, or you can find the specific time or date or the location you entered. It's a somewhat tricky part to find out the data from the TIDES database for your reference. Okay, any other comment or question?
Hello, this is Sunny speaking. I am a little bit curious about the standard method. Can we say this is standard method actually?
We can say it as a traditional method or especially for visual counting.
Anyway, this is very interesting paper. I really appreciate Jason choose this one, and I totally agree with the Boris's opinion, comments. And it is really difficult to apply the citizen science directly, and we need some training to assign surveyors along the riverbank, or and should give some training on how long, how exactly detect the floating or riverbank marine debris.
From the chatting window, Jong-Soo Lee also agreed with Boris, and she pointed out that we need some kind of training for the surveyors if we want to apply this method as a citizen science project, citizen science survey.
Jason have to leave because of his baby.
Okay. Any other comment or question? I have two things to want to point out in some technical part of this paper. First thing is missing data from so-called standard method. The big difference from two methods was from the missing of a standard method, but I think the entering the result for cloud water is also based on the counting of the debris, but I think it also takes some time for surveyor to count the number of floating litters from the surface of the river. But they said that the observers who use the cloud water can resist the data from peak time, but the observers using standard method missed the peak data. I think there was some kind of technical treatment of the observation or recording. And next thing I want to ask is from figure 5. In figure 5 and text, they said they used the correlation test from Pearson's correlation, but in the caption, they suggest that they use Spearman's correlation. I think the the number of data is only 6, so they should use Spearman correlation for non-parametric data. But in text and figure, they are suggesting Pearson's correlation. So I think there are some error in this part. Okay, that's all. Okay, do you have any other comment or question? No? So I think we should wrap up this seminar without Jason, who are the presenter of this seminar. But I think we all understand Jason was very good at explaining the contents of the seminar, and he is a very good father too. Okay, shall
Yes.
we talk
This
about?
this is the last one of this year.
Yeah.
And we will meet on next year, 5th of January.
5th of January.
Some of us, OSEAN will choose one paper and share it with all of you.
Okay. Thank you, Sunny.
Happy you guys, Happy New Year.
Okay, bye-bye.
It's a little bit
Bye
early.
bye.
Bye bye, you too.
Bye
Okay.
bye.
Bye-bye.
See you next week.
Bye-bye.
Next year.
See you next year.
Okay, bye-bye.